Now we'll discuss the properties of an acid. As you know that what actually the acids are, what are the classification of acids on different bases, you know that how we can prepare acids. So now I'm just making you learn the properties of an acids. So see, acids are sour in taste. That means most of the acids, or you can say maximum 99.9% of the acids, they are actually sour in taste. And they are corrosive in nature. You know what do you mean by corrosive? Corrosive means like if the acid gets poured on my skin will get burned. Why it get burns? Because it actually extracts the water from the skin and leaving behind the dry skin, that leads to the burning sensation. So we say acids are corrosive in nature. Third is that, see, the acids are liquid at temperature, but we have few acids which exist as solid as well. And the acids act as an electrolyte. You know that what is an electrolyte? Electrolyte is actually a substance through which electricity, like when electricity is passed, it just gets dissociated into ions. So it is an electrolyte. That means the aqueous solution or an acid, they are good conductor of electricity. When we just pass the electricity from that, they get dissociated into the ions. As I am showing you here, suppose I have hydrochloric acid. When we pass electric current, it gets dissociated into its respective ions. Next, see, we have indicators. You know what actually are the indicators? Indicators are actually the chemicals which when added to a substance just bring about the change in themselves, indicating the nature of the substance. And we have many indicators. We'll be discussing indicators in a separate topic. There are natural indicators, there are artificial indicators, there are olfactory indicators. So we have a variety of class and variety of indicators. So here I have few indicators for you that will just explain that what is the effect of acids on them. So like we have the litmus, so the acid turned blue, litmus red. Right, see, original color of litmus is purple, but when it is used in lab, it is used in under two classes, or you can say two colors. We have blue litmus and we have the red litmus. So acids do not show any effect on the red litmus, but they do show the effect on the blue litmus. What effect? They turn blue litmus red. Second, we have methyl orange, whose original color is orange. So what happens when we add acid to it? The methyl orange turns pink. Next we have phenolphthalein. So phenolphthalein, again, when acid is just added to it, remain colorless, and when the base is added, it turns into pink color. So but we are not concerned here with the bases, so you need to remember the effect of acid on phenolphthalein. So what they do, they just make it colorless. So these are actually the properties, physical properties of an acid, which we can feel by just looking at physically, or by just adding certain things, or by passing an electric current. Now coming on to the chemical properties, so we'll be just starting with the many chemical properties, that is the reaction of acids with metal, reaction of acids with metal oxide, reaction of acid with carbonates and bicarbonates, reaction with sulfides, reaction with bases. So I'll be just stating you with an example, and as you are familiar with the valencies, so you'll be able to do these reactions in a proper manner. As see, I've told you that the basic of the chemical reaction is the same. So see the example, suppose I have an acid, say HCl, and I am adding any metal. Suppose I take metal Na. So you know that what we are going to get? Yes, it will form the respective salt, and what do we get along with it? We get the hydrogen gas. So this reaction is actually shown by most of the metals which are reactive than hydrogen, right? I should mention that this reaction is shown by those metals which are more reactive than hydrogen. So what happens when they react with acid? They form the respective salt, and along with that the hydrogen gas is evolved, which burns with the pale blue flame. Right, and if there is if there is an air, that means when the hydrogen get mixed with the air, it produces the popping sound. So this is the reaction with the metal, that they react and they form the respective salt, along with it hydrogen gas is evolved. Second is that the reaction with the metal oxide. So when suppose I have an acid and I have the metal oxide, say I am taking a metal oxide, suppose calcium oxide, right? So what do I get to have? So that means they will form the respective salt again, that is the calcium chloride, and what we are left with HNO. So obviously what we are going to get? We are going to get the water. So that means when they react with metal oxide, they form the salt, and along with that we get the water. Third is that the reaction between the acid with the carbonates and the bicarbonates. So suppose I have the acid HCl again, and carbonate which I choose is suppose Na2CO3. So what you can make out from this reaction? See, N is, I'll just write the valencies. It will be easier for you to just interchange them. So you know that this positive one is going to react with this, and these are going to react with this. So obviously we are going to get NaCl, and along with it we are going to get carbonic acid. So this is how we are going to do the reaction with the carbonate and the bicarbonate. And if I just state an example with sodium bicarbonate, so again what I'm going to have NaCl, again I'm going to have the H2CO3. So that means again the same product. And what happens when we react metal with sulfides? So acid, suppose I have the acid HCl and I have some sulfides, say I take an example, sodium sulfide. So what kind of reaction do you wish to have? So see, here is like this. So that means Na will be combining with Cl and we'll get H2O, and what other gas? That will be SO2. So this is how we are going to do the reaction of acid with the sulfides. See, as you are familiar with the valencies, as you know how the reactions just take place, so it is very easy, just like if when you get the reactants, so just write their valencies and just interchange their partners, right? So this is how we have done. Again, reaction with base. See, acids are those which actually have the hydrogen ion. Suppose I have chosen the sulfuric acid, and the bases are those which have the hydroxide ion. That we'll be doing later in a later section, right? So like this. So what we are going to have in this, it will form the salt, and with the salt we'll have the water. So this is calcium sulfate, right? So how this reaction took place, I'm just writing the valency here. So they are just interchanging their partners. So this is how we can say that the chemical reaction take place when the acid react with the metal oxide, metal carbonate, bicarbonate, metal sulfides, and with the bases. And one more thing I would like you to know, that see, metal oxides are basic in nature, right? And this is an acid, and you know that when an acid react with base, they lead to the formation of salt and water. There is a special name which is given to this reaction called as neutralization reaction, right? The similar reaction we get to see here. See, this is an acid, this is an base, again a neutralization reaction which leads to the formation of salt with water. So this is how I think it's clear that what are the physical properties of the acids and what are the chemical properties that we did with the chemical reaction. As I took the example according to my wish, you can take an example of any acid or any other metal oxide or any other metal or any other metal carbonate. See, the product is going to be same in the case. The general substance formed will be same. It is just a matter of the metal which we are using or the salt which we are using. So otherwise the general, the method of attempting the reaction is going to remain same.